Okay. So the project that Andre, Justin, and myself have been working on is called Ghostwriter. Next slide, please. The UN predicts that 2.2 million books are published every year, and I can guarantee, especially for the narrative ones, that all the authors experience writer's block. Not knowing what the next character action should be or the next plot point in the story should be, this is where we hope we can use Ghostwriter. By giving it an input of something you could see on the left there, Ghostwriter will make a creative yet logical continuation using the ideas already established in the story. Next slide, please. We focused in on the science fiction genre for this project, and we used short sci-fi stories from Reddit as submissions, as well as excerpts from the novels in the Project Gutenberg science fiction library. Next slide, please. One of the main process things we had to do in the beginning was understand that Project Gutenberg had unique chapter delimiters between each of its stories. So we had to try and take our multi-paragraph excerpts from around the center of the chapters or center of the book to try and minimize the effect that would have on the data set. Another important thing we had to do was realize that Reddit used non-UTF-8 safe characters, like you could see on the left. So we had to make the analogous changeovers with, excuse me, within our data. The next thing was the spacing. Reddit likes to add a new line character to the end of each line to give it a square shape to its text, but we didn't need that. We just need the double new line delimiters to understand where the paragraphs ended and started. So we had to go through and strip the new lines from the end of each of the lines. Next slide, please.
So our project is built off of transfer learning using GPT-2. So to understand GPT-2, we first need to look at a decoder block, which is shown on the right. At a high level, a decoder block is essentially comprised of three components. The first two are feature and characteristic identification layers, which feed into the last component, which is an MLP that outputs a vector of probabilities. And so for GPT-2 itself, it's made up of an embedding matrix followed by a series of 12 of these decoder blocks, where the output of one decoder block is sent up to the next one in the series until the output of the last decoder block is used to predict the next word in our story. And so during training, we froze all layers except for the MLPs in the last two decoder blocks. We did this so that we could freeze those feature identification layers while also allowing our model to train. And we empirically found that leaving two MLPs unfrozen was appropriate, since any more would cause overfitting and any less would underfit the model. Next slide, please.
So getting like a initial accuracy to judge your model is kind of very hard with this project since it's creative writing. So we sort of had to rely on as a first approach to the loss to judge the viability of a model at first glance. So you can see with our best model on the left, we had a much lower model validation loss than say the one on the right, which was one of our worst models. So that was sort of our initial sort of approach to judging it. Next slide, please.
So yeah, as Daniel mentioned, one of the biggest challenges of our project is actually how to quantify the quality of a generated output, which is actually actively being researched. So to overcome this, we use popular metrics from other simpler NLP tasks, kind of like translation or summarization. So the three we used are blue and rouge, which are used to compute the number of overlapping words between the ground truth and the model continuation, and latent semantic analysis, which we use to compare similarity in meanings between sentences that are found in the ground truth and model continuation. Next slide, please. So then another challenge that we face is how do you generate a ground truth for a problem where one doesn't really exist? Well, to overcome this, our solution was to split our input story into two and take the first part as a prompt for our model to continue, and the second as a ground truth, which actually kind of acts like a pseudo label, and when paired with the generated output, creates a score. Next slide, please. So here we can see a table summarizing each of our models' scores on the various metrics. The best performers in each metric are highlighted in green and the worst are bolded. So the second table actually is used on a different output set with very similar prompts. This is to show that how volatile these metrics are given the infinite potential outputs that the models can have. So as a result, our group primarily focused on qualitative metrics when comparing our models. Next slide, please. So here we can see an example of some of the analysis that our team did when we were comparing our model with our baseline. So on the left in the yellow highlights, you can see things that we didn't want, which were like introduction of non-fictional elements. Here it talks about blogging and Star Wars or excessive repetition. Whereas on the right in the green highlights, we wanted to see things like creative introductions of people and places that authors could reliably build off of. Next slide, please. So once we narrowed our model choices down to our best two, we sent out a survey to non-Ghostwriter member participants, and they had three stories, and they would pick their favorite continuation between option one, which was the baseline, option two, which was the second best model, and option three, which was the best model. Participants were chosen from a wide range of backgrounds, education, and interests so that we kind of captured and weren't biasing our data towards a specific set of people. And then we also kept each participant blind so they didn't know which model produced which. Next slide, please. So on the left, you can see what the survey that we sent out actually looks like. And on the right, you can see the responses that we're going to go into now. Next slide, please.
So from our qualitative results, we can conclude that our model outperformed the baseline. In our survey, we observed that for the first two stories, our model highly outperformed the baseline. And even for the last story, our model performed comparably well to the baseline. And also our quantitative results support these qualitative findings, even though the metrics for the quantitative results were volatile. That being said, we didn't have a blow-up victory by our model that we were expecting. And a theory as to why we have these shortcomings is a lack of focus. Our group wanted to focus on a specific genre, but other successful projects that we've seen focus on either one author or even one franchise. And so if we were to redo a project similar to this one, we'd focus on either one author or use a data set with many samples for each author used so that our model can not only learn fictional elements, but can also develop elements of a creative style or author's voice.
Okay.
Next slide, please.
No, that's it. Thanks. Good. Fascinating piece of work. Really, it looks like you really did lots of interesting explorations. I have a whole pile of questions. First question is, I didn't catch what you mentioned, what your baseline was. I'm guessing it's just a straight up GPT-2. Is that correct?
Yes, that was it.
Pre-trained out of the box.
Which size did you use?
We use the LM head model, and that's roughly the same size as the small model.
Small model, yeah. And so you're up against the baseline. You're kind of sorry. Which of these colors is the baseline?
Blue.
The blue one is the baseline.
Okay, so so they liked your continuation best 59% of the time. Oh, for story, I can't read this. I'm missing this. This is story 1, story 2, and story 3. Okay, so it's 3 different stories.
Mm-hmm.
So you did well in the first story, but not the second. And the second one. Sorry, what is the red color?
So that's our second best model, or like what we presume to be our second best model from like our metrics.
I see. But that's good. Yeah. So you're testing kind of two things when you asked people this question. That's if I were to go back and do that again, I would test them pairwise just to see which one's better, because you've confused the. I was going to say if you come out even up against GPT-2, then maybe you haven't. It's hard to claim a victory, but it's even harder to claim when you've got a 3-way competition. So. Yeah, that's a touch confusing. That said, by the way, I'll back up and say, yes, you have a devilishly nasty problem about how to measure the goodness of it. And I really admire all the different things you tried. You were playing around with these 3 things. I would have been most interested in the latent semantic analysis. That is the similarity between the 2, and that's in this somehow. Sorry.
Yeah, it's on the yellow on the right.
Oh, okay, I had that covered up. Did you have any sense as to whether that metric corresponded to what you thought was a decent, unblocking sentence or 2?
It was difficult, but like our reasoning of using it was, any time that we had to.
To be clear, let's make sure you get the question.
Oh.
Did you look at these numbers and see if they corresponded to your own sense of whether there was a good continuation or not? Do you understand the question?
Oh, yeah. So I was just gonna say that it didn't really like map super well. Like in our internal initial testing, like our best, I think, model, which we liked the continuation, didn't have like the best similarity.
I see. So that's why you went on to this kind of human-based.
Yes.
Interesting. Just a comment. I think in a presentation of this length, it's too short to go into the depth of description of GPT-2 that you attempted to do. I admire that you did that. I had hoped actually to teach those transformers in this course, or at least have an optional way to go there. But it's a pretty complicated beast to get through, as well as everything else here, including things like blue and rouge scores. This was a great idea, by the way. I like this a lot. I just as I saw it, as a way to find labels. I lost it. Where'd it go? Yeah. yeah. I think this is an example of, gosh, how do you find labels? And and that is actually, I hope it's one thing everybody's picking up in this class, that this answer, like how do you find decent labels? And this is a clever way, I think, to get them. Just take the right answer from an existing story. And so maybe it seems obvious now, but I bet it wasn't obvious at the beginning to pick them.
Not at all.
Yeah. So I just want to compliment you that, and I just want everyone else to maybe pick up. It's a really crucial learning that this is a clever idea, and these clever ideas are what really advance any given project. Where you know you've got this machine that if you've got good labels, it'll work, and so that's great. Imtihan, any comments or points?
Yeah, good presentation. I have some nitpicky things that I'd like to talk about, but overall, I liked what you guys did.
Okay,
One,
nitpicky though.
yeah, not too nitpicky. One, when you're describing the GPT-2 model, it's a transformer model. Just make sure to say that it's a transformer model. I think you guys went directly to call it a decoder. So just one thing there. Some of your slides are a bit crowded. You don't describe early on what the input to the model is and what you expect the output to be. So that's very important to say. The loss you use, what is the loss measuring? And when you start, it's the same as for the last group. Start with what you're doing. So the first sentence in your presentation should be, we're trying to address writer's block with our project. Yeah, that's pretty much it.
Great. All right. Well done.
One thing that I'd like to jump in on, yeah, great presentation, guys. Just for the pie graphs, it would be helpful if there was a statistical test associated with the number breakdown. So you can use like a chi-square test or something, or a Fisher's exact test to generate if the difference is actually statistically significant.
Differences like between these fellows, like 43.
In performances, yeah.
Oh, yeah, that reminds me of another thing.
Before you go there, that's a great point, Phil. Thanks for asking it. We don't ever dive into that in this. So I'm going to take a more advanced statistics course next term. But you have taken one stats course, and you do know chi-square test. Is that correct?
Yeah.
So there's not a lot of space to do that, but that's a good point. Okay, quickly, Ahmed.
So for your options, one of the options is from the actual text itself. Is that correct?
For the survey option?
Yeah.
No. So it comprised of only the baseline output. So that was just the out-of-the-box GPT-2, how it continued the story. And then two of them were from our models. The red section is from our second best model, and the yellow one is from our best model.
Okay. Well, like you had the data for the actual continuation, right? So I think it would have been a good idea to compare against that to see how well your model compares against what real human writers are able to come up with.
Yeah.
I guess if you could score, it's an interesting point. If you could score 50% against the real answer on a head-to-head, not the three-way thing. The three-way thing gets confusing. That would be 50% would be a win there, because you go, we won half the time. People, we were equally likely. So that's an interesting point. Yeah.
And that's the important metric, right? You don't care about beating other models. You want to be as close to human as possible here.
Yeah. Okay. Thanks.